Hi, my name's Amy Boyd. I'm a cloud developer advocate here at Microsoft.
Hi everyone, my name is Stephen Simon and welcome back to CSharpCorner live show. In this episode of Ask Me Anything series, we have Amy Kate joining us from United Kingdom, who is the cloud developer advocate. Hi Amy, how are you?
Yeah, very good, thank you. Very good. What an incredible introduction. Oh my goodness. I'm going to have to ask you if I can borrow that. That was perfect.
As I didn't tell you, I was always telling you there will be a video followed by the countdown. So I just wanted to keep it surprise. So Amy, why didn't you go ahead and tell who, I mean, we had an intro video, but still I think the audience would like to know, right? We have people joining us from across the globe. CSharpCorner is a global community, and you are coming on a platform for the very first time. So people would like to know, who is Amy Kate? What does she do? Where she lives? So why don't you go and introduce yourself?
Sure. Yeah. So hi everyone. My name's Amy Boyd. I am a cloud developer advocate at Microsoft. What does that actually mean? Because that's quite an unusual title. It's only used in the tech industry. And basically, what I get to do is I like to think of myself as sitting in the middle of community and developers on one side, and then our internal engineering teams on the other. And so one of the things I really enjoy doing is using our technology, sharing use cases for our technology with any developers and data scientists, but then actually hearing from all of you people as well out there who are using our technologies and taking that feedback back to engineering, so that we can make sure that our products are exactly what people are looking for, as well as being hopefully exactly what you want to use to solve your problems.
That sounds really interesting job profile, Amy. I mean, you work as a mediator between the products team and the community. You get an opportunity to work to understand what is very happening with the products, and then you also get a feedback from what is happening with the community. Truly sounds very exciting. We also know you have been in this Microsoft for a very, very long time, and you are known for your community stuff. So is we have for you today. So, Amy, what are we covering today? I mean, it does say automated machine learning with low code.
Yes.
So what will be the basic agenda, and what are the target audience that we're looking for today?
Sure, yeah. So, yeah, as the title suggests, we're going to talk about something called automated machine learning. It is something that is used across the industry. So it's not just a Microsoft thing. But what I'm going to show you is in Microsoft Azure, we're going to have a look at the machine learning service. Now, don't worry if you've not used it before, it's not a problem. We're actually going to focus on the low code element. So we're only going to focus on UI elements, as well as things like REST API calls and some JSON code. So really, don't worry, we're not going to be, there is a whole, obviously, like Python and R SDK available for this technology. But I felt actually to introduce these concepts, it would be easier to show you and walk you through it using the UI.
Well, that sounds very interesting, Amy. And I think you can go ahead and maybe if you want, I can bring your screen into the stream. I think low code is something that is really getting popular these days. And it may be a Power App, it may be UI flows. Even Microsoft is committed to enhance the technology with the latest features. So it's all you now. I will be there in the live stream. People will be able to watch it, but it's all you. guys can see your screen, and there you go. I love that. You know, I love that.
I
Escort.
know. I was going to say, of course, we have to have Bit on the screen, our mascot. And I don't know if you can see on camera, but we have a physical one just here as well. He sits on my desk with me all the time. But yeah, should we get started?
Yeah, sure. It's all you now, Amy.
Perfect. So yeah, like huge thank you everyone for joining us. We're going to be talking a bit about automated machine learning and reducing that time to insight using low code. So the main driver here is to share with the developer community some of the great tooling and powerful machine learning offerings that are out there without having to have extensive machine learning knowledge, Python coding, R coding, etc. There is a really nice spectrum, I always think, of all the different services we see. So we can see something like what Stephen just mentioned there, which was all the stuff around Power Apps and Power Automate, and the AI builder in there is absolutely phenomenal. It's a really amazing service, so powerful and yet so easy to use. Then you might come down the spectrum a bit to something like the Azure Cognitive Services, quick REST API calls to get your machine learning knowledge back. Very, very low amounts of sort of deep technical knowledge needed. And then we start to run into the Azure Machine Learning space. And in that space, we have things like, you might have heard of the Designer or Automated Machine Learning. And then also for all the experts in the industry, so thinking of your data scientist type persona, people who code in Python and R, they use things like Jupyter notebooks. We have a lot around the SDKs that work alongside our Azure Machine Learning service to really make sure you have that enterprise, end-to-end, production-ready machine learning service. And so we're going to sit right in the middle. I am going to talk some machine learning concepts. However, we will walk through that. There is loads of amazing documentation. I'll post some great links in the chat for you so that you can continue your learning. But I just really want to show you what's possible and give you an idea of the types of things that you can solve using this. So first things first, right? What is automated machine learning? Because actually, machine learning, I've always thought, is quite automated. Just like code, if you write, a few lines of code and then basically loop it, you're going to be going through many, many, many pieces of data in order to train a machine learning model to understand your problem. So machine learning at its heart is very, very automated. However, let me tell you not what automated machine learning is, but why it came about. So in the machine learning space, one of the things that you find is that you're doing a lot of tweaking. So even once you build a piece of code that does something for machine learning, it's never really like the first thing that you write that's actually going to be useful. You've really got to experiment with it. So let me give you a scenario of what we do here. So an example scenario is, how much is this car worth? And we have lots and lots of data based on lots of different cars. And what we want to do is we want to teach a machine learning model how to understand or give us some kind of probability of prediction of how much it thinks this specific car is worth. And so one of the things that comes up when we start building is that actually model creation is very time consuming. So when we're writing this code, we write one set, and for each time we build one model, the first thing we do is we say, well, which features, so whether it's mileage, car brand, the year the car was made, and then we might need to look at, okay, well, which algorithm am I going to choose first? And then each algorithm has different parameters. So for example, on my first try, I might go, right, I'm going to pick these 3 features. I'm going to choose this algorithm. And then this algorithm has lots of different parameters that I need to set. And then out of the end of that becomes a model. And that model has some form of evaluation metrics. So this is a generic evaluation metric, but it might be something like accuracy. It might be something like precision. It might be something like squared error. So measuring the difference between the true value. And in this case, our first model, we only get 30% accuracy. It's not great, right? We want to improve it. And so what we'll do is we'll then put that one to the side and we'll iterate. So we'll change all of our different values. So we might choose different features, a different algorithm, set our parameters differently, and then a new model comes out. But we then have to do that over and over and over again until we finally find our 95%, our really good, accurate, well thought out machine learning model. Now, all of that takes so much time. And this is where automated machine learning came in to solve this problem for data scientists. And so we choose to basically, in automated machine learning, we pass it an input. So we give it our data. We define the goals we want it to do. So a goal might be, is this a classification problem? Is it is something true or false? Is it category X, Y, or Z? Or we might do a regression problem. So that is how much or how many. So in the case of the car, this is a regression problem. How much is this car worth in a currency amount? And then we might apply some constraints, some things like we can only use certain pieces of data, or we can only choose certain types of algorithms. That might be for policy reasons, that might be for training amount of compute reasons. So for example, a neural network, which are very, very popular, are very powerful, but they do take a long time to train. And if that becomes an issue, sometimes you might have to apply that constraint. But basically what we do then is we give it this setup and it will go away. The automated machine learning service will go away. It will test all of these different setups, just like we would have had to do physically ourselves prior to this. And then what it will do is it'll actually give us a list of all the different models that it was able to create, as well as producing that final optimized model. And so really, like, this has been a really interesting progression in machine learning for data scientists. However, this has also allowed a lot more people to get involved in machine learning as well. Sometimes the barrier to entry is the need to apply the code and the packages and the frameworks and stuff like that. And you know, that takes a long time to learn. And so to actually be able to just pass it data and design your problem, but not have to physically execute the problem, it will do it for you. This has actually meant that people who aren't experts in the machine learning space, but might work with, say, like a data analyst or someone, you know, if you have a kind of a data savvy mindset and you're keen to learn about things like evaluation metrics and asking yourself, like, why is this approach to machine learning the right approach? So am I answering my question or asking my question in the right way? And so I do think this is a really nice happy medium in some senses. Okay, and so first things first, that's automated machine learning. So automated machine learning is the process of efficiently trying lots and lots of different algorithms and setups to try and solve your machine learning problem. The automated piece means that it automatically runs through these and provides you both the optimized model as well as all the other models that it ran. And from there, you can go ahead and then deploy your optimized model. This has also massively reduced the amount of time it takes to get models to production, especially when it comes to more what we now call more traditional approaches to machine learning that are basic classification, regression, time series forecasting modeling. It's absolutely perfect for this. And so what I want to do with kind of the rest of the session is show you this in action with two different scenarios. So the first scenario, we're going to look at one problem, and then the second scenario, we'll take a quick look at time series forecasting. So let me introduce you to scenario number 1. Okay, so scenario number 1 is from one of our favorite fictitious companies. It's called Tailwind Traders. And Tailwind Traders are a fictitious retail company that do it-yourself type home DIY. So think of things for your garden, plumbing, electrical, tooling, stuff like that. So they're an online website as well as an in-person store. And what they've had is the Tailwind Traders development team have created this fantastic website and also a native application. But as with any technology, once people start to use this, so this might be people, customers, as well as partners, often people will find maybe issues with an application or a website. And when they find issues, they often send in support tickets or feedback tickets. And so the Tailwind Traders team have an amazing support ticket system. So as these support tickets come in, they have a great team who are there to triage all of the different tickets that are coming in and hopefully either solve them very quickly or send them on to someone who is going to act on them. Unfortunately, these support tickets keep flying in, and the support ticket team are starting to feel a little bit overwhelmed with the sheer amount. So the more users that use it, the more support tickets that come in, and it is only a very small team. Now, they did tell us that actually a lot of people go away very happy with the service. They get their problems solved very quickly and efficiently. However, unfortunately, some people are not getting that great experience. And so the main question here was from the Tailwind Traders leadership team. And they asked us as the data science team here, they basically said this: how can we help the support team? That's how broad the question was. And so one of the things around solving these problems is often the first question that is asked of a team to dive into data is not the question that you might automatically be able to apply automated machine learning to. And so one of the things here is we're saying this is a super broad question. We could help the support team by not needing data at all. We could just say, hey, right, we need more headcount or more budget over there if we can find it, or right, we need to have a dedicated technical team that's going to work on this as well. Like, it could be a personnel or a cultural thing. But when we started to dive into this data, so we have a tabular data set where each row in the data set is a support ticket that's been submitted from the past. And one of the things that we found was actually the duration of these support tickets is very, very interesting. They solve a lot very quickly, so between 1 and 2 days. And then there's a bit of a dip in the middle, so that kind of 4 to 5 days. There's not a lot of support tickets sitting in there. And then unfortunately, towards the end, the 8 to 9 days of the graph, the support tickets start to rise again. So there seems to be some very, very quick to solve problems, and then some much longer problems that need to be treated quite quickly. And so one of the things we wanted to test was actually if we were able to predict the duration of a support ticket as it landed in the support ticket system, could we then be much more flexible about our staffing? So when there's more support tickets and more work on, can we make sure that we have kind of more staff ready to help out with that, so that people can quickly triage the easier to solve ones and also spend more time working on those longer tickets, those more complex ones. And so what we're going to do is we're going to try and predict the duration, the amount of time it will take to solve a support ticket. So let me go ahead and show you how we can do that. So I'm going to, apologies.
Amy, let me just pop in. I'm glad you didn't take the company name as Contoso book or something. Contoso.
Yes.
That is something we always say quite at Microsoft. Contoso book, Contoso menu. Maybe
I was going to say, and it's Yeah, and no, Tailwind Traders is something that we've been using at Ignite on our tour in the last couple of years, and it's quite good because Tailwind Traders are a fairly large business, and so we can apply most technology problems to their business. And in the data space, they're actually very, very good. So it's an exciting time. But yes, so we are obviously as a team here going to be working to try and solve that problem. So first things first, I just wanted to quickly show you inside the Azure portal. If you're familiar with Azure, if you go to the top menu and you click Create a Resource, and she says. And you type in machine learning, it will then come up with this little sort of blue canonical glass just here. And what that will mean is that is the Azure Machine Learning service. You can use a free type tier, so a basic tier we call it, and in that one you can just use the SDKs and the notebook experience, and you just pay for the compute. Because we're using automated machine learning and it's a service, a bit like the designer, we will need the enterprise version of Azure Machine Learning service. And if you need to find the pricing, do go ahead and go to the Azure pricing calculator, and that will help you understand exactly what that means in your monthly bill. But I do have one that I created earlier, so we'll use that one, and it's called Ignite the Tour because it's something I've been using for quite a while. And when you create the service, a lot of what sits in the actual Azure portal is all around the management of the service. So thinking about who has access to the Azure Machine Learning service, how does that service have access to data sets, being able to track and monitor the usage of this kind of stuff for policy reasons, stuff like that. So a lot of really probably the IT pro type side of the house is going to spend more time in this part of the portal. And what you'll notice is it tells you all the different things that it's associated with, that it creates. So it does things like App Insights, you have a key vault, you have a storage account associated with it. And if you click on, what you'll notice is the big square at the top is something called the Azure Machine Learning Studio. And this is probably where I spend most of my time. And so when you click Launch Now, it takes you to this studio experience and it pops out into a separate browser window. This is the place where I tend to go and physically do the machine learning type work. And so I see this space more for the developer type of role, as well as the data scientist or the data analyst. So just to let you know kind of the difference between the two, you'll spend most of your time actually in the Azure Machine Learning Studio. And so we're in the portal here. We can see that I've been running some stuff prior to this. And if we scroll down, we can see I've got things like compute that I can actually attach to my experiments. And so this whole Azure Machine Learning service is all really about the end-to-end and the full management of creating machine learning models. So if you want to find out more about that, definitely do go to something like Microsoft Learn and search for Azure Machine Learning. That'll take you through the real basics of, why would I use Azure Machine Learning? In this talk, we're going to focus on just a few elements of the portal. So yeah, definitely do go and find out more. I actually see there's a question that we're going to answer very shortly in the live comments. So I'll be back with that question very quickly. But let me just move my laptop very slightly there so I can see by the screen. There we go. So what we're going to do is under the tab on the left, so we can pop this out. There we go. You can see we have lots and lots of different categories. So here is where we can create different things. Here are all our assets that we actually create. And this is all of our kind of management section. And so if we go into assets and we take a quick look at our data sets, we can see I've uploaded quite a few different data sets, or you can connect to different cloud storage as well. So you can register a data store so that you can have lots and lots of different data sets within a single store, and you don't have to move things about and have them in all different places. One of the things you'll notice is you can do things like versions of data sets, which is so useful with machine learning because you edit and change data sets over time. And if we take a quick look at the support ticket system data, just let it load that data set, you'll notice that it comes up with lots of details all about where the data actually sits. But also, if you click on something like Explore, it can give you a very, very brief summary of the actual data set. It's often very useful just for understanding, okay, like how are we going to approach this problem? What does this data look like? And so here you'll see this is what our support data looks like. We've got lots of great data in here. We've got things that we do and don't want to use, but basically our data set is uploaded and you can do that very easily under that data sets tab. But let me show you automated machine learning. So if we open our little menu here, it's running a little slow. I think it might be my...
It has happened with the internet, right?
I know, nightmare. I just streaming. I was flying through it earlier. Here we go. Right. So then we can see automated machine learning is here. So if we click on automated machine learning, and it takes us to this UI page. So as I mentioned, you can actually do this via the SDK way. So you could use code if you feel more comfortable doing it that way. But we're going to look at the UI version, which really takes you through step by step how you can approach this problem. We can see I've run quite a lot already, and we will revisit these because, as you can see, they take around 30 minutes to run. So I'll do a here's one I made earlier type thing in a moment. So we'll go to new automated machine learning run. And you'll notice that you get kind of the breadcrumbs of the different areas that you're actually going to do to set up this. But first things first, we need to select our data set. So we will select our training data just here. And we'll click next. So as long as the data set is associated in the Azure Machine Learning portal, then we'll be able to easily select it within here. And if it's not actually already there at this point, you can also upload and create that data set. So it's not like you have to be like, oh, have I done this? Have I done this? It does all take you through that situation as well. And so data set, and I'm going to create a new experiment here. So an experiment on some senses, like everything around one single project you would want to keep in the same folder. And so I think of experiment name like that. And then we'll run lots of different experiments inside that one experiment name. And so if I enter Tailwind Traders, support ticket V2, that's our ticket, there we go. And under target column, this is where we start to define our actual automated machine learning run. So under target column, I'll drop down the options, and we can see that all my different columns in my data set have come up. And we said that we want to predict the duration of a support ticket as it lands in the support ticket system. So I'm going to select duration here. And then one thing that you'll notice is it then asks for some form of compute. So down here, you can set up something called machine learning compute, which is a scalable form of compute. So rather than a virtual machine in the cloud where you pay for whenever it's on and then you have to go and deallocate it or set up a time for it to deallocate itself or shut down, machine learning compute is very, very clever in the sense that when it's being used, it will scale up the nodes that it needs to use. And then the minute they become idle, after say 2 minutes, 120 seconds, it will scale it back down again. And so you literally do only pay for the compute that it takes to run your experiment. It's a really exciting part of the machine learning platform. And it also means I no longer wake up in the middle of the night in hot sweats, worrying that I have like a GPU machine left running and not doing anything. So this has made my life so much easier. And so this isn't a huge data set. And so what we're going to do is I have a CPU compute cluster. So think standard developer virtual machines, 4 nodes, something like that. And then I also have a GPU compute one available to me. I'm going to choose CPU compute, and I'm going to click next. If you needed to create compute, again, you can do it during the process. A little panel will just pop out at the side and you'll be able to do that. Okay, and so now we're actually defining the task that we want to do. So we've given, oh no, don't do that. Sorry, I think it's lagging a little bit. Apologies. Let me quickly try that again.
By the time you do, Amy, I think something that really interests inside the Azure ML Studio is like you started with the data set and all that without even uploading even a single Excel file or a CSV file, which tells us Azure Machine Learning Studio comes with tons and tons of data sets, starting from very basic, this Iris data sets to even this car, then Titanic data set. Now, even there's a data set called Penguin, which is very famous, right? So you don't have to upload anything. You just have to select the data set in which you want to go and get started, and there you go. I think that is something I feel is very something to take away from last couple of minutes.
I was going to say, and I've got a link actually at the end that I'll share with you that is super interesting, because a lot of the notebooks and examples for the whole Azure Machine Learning Studio all come with a scenario and a data set that's associated with it. And so, for example, the forecasting experiment I'll show you, I actually ran through the forecasting example that the Azure Machine Learning team offers, and then I applied it afterwards to my own data set. And that just made it like really a lot easier to understand the approach. So let me just, quickly go back to over here.
Something like a cheat sheet that you can refer and get started.
Yeah. And also, like, you can easily copy them if you are using like the notebook experience or something like that. You can actually copy them into your notebook experience, because it's just like a GitHub clone, and so it copies everything in from that GitHub. So it's really cool. So apologies for that, I clicked too soon. But basically what we're going to do is we're going to do a regression problem. So I'm going to click on regression here, and also to note there's some additional settings that you can set. And so things like the primary metric. So this is, how do I want it? What do I want it to optimize on metric wise? And so for a regression problem, I often use root mean squared error. It's quite a good one for basically you do the measurement between the actual value and your predicted value, and then you draw a line between them, and the line is the amount of error. So the closer they are together, the error is smaller. The further they are apart, the error is much bigger. And then the squared part of it means that when we look at, say, like a normal distribution, what it does is it punishes the ones that are much further away because it squares them. And so then when it's only small amounts, it'll only square it by a small amount. But when it's, say, it's doing really, really good in the middle of the data set, but actually when it's on the extremes, it's just predicting things that make no sense at all, then it'll punish it because it'll have a much larger error. And so it's a nice measure for regression, but I mean, all of them are. This is an interesting piece. We've gone huge at Microsoft on responsible AI, and part of responsible AI is interpretability and understanding what is affecting your machine learning models and the outcome. And something that's been built in is this explain best model. And so what it will do is it will analyze the model it's created for you, and then you can dig into it and look at the specific data points and actually start to understand, say, what columns in your data set are heavily affecting the model and stuff like that. And so you can analyze all of that great stuff. I mentioned you can actually block algorithms. So say we don't have a lot of training time or a lot of compute budget, for example, I could block like neural networks or really big algorithms, but we're not actually going to do that. you can set the training time. So I'm going to say after an hour, I think we'll have enough to work on. And so you can set basically how much do I want this to really go into all of the different options that are available. Because if you've got a really big data set, this could take a long time, right? That's the payoff in some senses. You're giving it a lot of control and it's doing a lot of great stuff, but it will take time to run through all these experiments. You can also look at things like validation and concurrency, but we'll keep them as they are. And then you can also take a look at things like the feature settings. And in here, you can actually then start to even take things out of your data set that you don't want in there for this. So we've tidied up our data set here, and actually this is everything that we want to use. But say you had like, so for the forecasting one, was a good example yesterday. As I was working through it, I was like, oh, I really don't need that specific column in there. But right now I'm just running with my testing, and so I'll just remove it from in here, and then later I'll update the actual data set version. But we'll keep ours as it is. And so all of those settings, we've basically told it what data set, we've told it our problem, which is we want to predict the duration. We've also told it some additional things to optimize on. And so then we'll click finish, and it will go ahead and it will take all of the information we've given it, including our data, and it will start to run over different models for us with different sets of parameters and different optimizers. One of the questions in the chat from Vina was, does it automatically do pre-processing of input columns? Yes, it does. And so what I will show you is some of the checks and balances that it does for you. So it checks things like, have you... it sits actually under this data guardrails column here. So once it's running, it will start to fill out all of these different columns, but it will look for things like, is your data set have high cardinality? So is there some data points that are really far away from other ones? Or does it have a lot of columns in it that are quite different? It'll also look for things like missing values. It can do some of its own pre-processing as well. And actually, when we look at the forecasting one, it does a lot of things for you in that arena. But let me show you on one that we made earlier what it checks on our regression problem. So we'll go to Automated Machine Learning. These breadcrumbs at the top are so useful. Instead of going back to always going back to this side, I always go back and forth between the breadcrumbs, because otherwise it jumps so far that you feel like you're making so many clicks. But that's a great question, Vina. Thank you for asking that one. If you want to find out all the details of the pre-processing it does, definitely go to the docs pages. And inside there, so let's go to Automated Machine Learning docs. There's a great section on this. So let me show you the docs, because then everything that I'll mention is sitting in there. So I think it's this one. And they have a whole docs page that talks through each pre-processing point that it does. You can also set it, if you're using the SDK, to not do certain pre-processing. When you're in the UI, you haven't got quite as much control as when you're using the SDK. So do just keep that in mind. We'll come back to that and see if it loads. And let's take a look. Does the service automatically choose a combination of multiple linear regression models and polynomial regression models? Yes. So it will choose a whole variety of models. Again, there's a documentation page that lists every model that it tries to look at. Some of them just won't work for your problem. And so it's almost a bit like of a meta approach, because the service has actually learned what tends to work well on data and will try those algorithms first. And that often cuts out its search tree on certain things. And so when we review one of our examples, one of the interesting pieces is actually seeing the the types of algorithms it does, but then it also changes things like the scaling and optimization that it runs. So the approach it does to that. And so you'll see like multiple of the same algorithm with different standard scalars and stuff like that. So yeah, once this loads, we'll take a quick look at that, but that's a great question. So yes, it tries a whole variety of different models. And again, as the service is progressing and maturing, when we look at things like forecasting in a moment, it's using some real cutting edge stuff like all of the ARIMA models and stuff like that. So definitely, I think as well, actually, there's another side to this coin. So Vina, you obviously potentially know quite a bit about machine learning already, and that's amazing. Yeah. But a lot of people might be like, "Whoa, like I don't even know what some of these words mean." Like, don't worry. Like the docs are really, really good for explaining a lot of this in very, very sort of clear terms that anyone can understand. But I do also encourage that when you see some of these models, and if you don't really understand what they are at their highest level, I recommend going and doing a bit of a search and kind of just spending a little bit of time to understand exactly what type of approach and why that might be applied best to your model, because it'll be interesting how useful that is moving forwards as well. So yeah, they're great questions. Which deep neural network library or SDK can we use in Azure? So you can use any deep learning library, any open source framework. If you want to use PyTorch, you can use it. If you want to use TensorFlow, you can use it. If you want to use Keras, you can use it. If you want to use a specific setup of BERT that is available on GitHub, you can use it. And the main thing here is to understand that we're looking at this from the UI, but the SDK is incredibly powerful. And what Azure Machine Learning is very good at is actually doing what I call the scaffolding. I think of it as all of the stuff that sits around the project. So your train.py file that you might normally create with a Python, with a TensorFlow framework or something like that, that stays as is. It's how does it run? How does it do the data pre-processing step? How do we get it to run on powerful compute in the cloud and then bring all those logs back to the center? And so there's been a huge focus on making sure that great frameworks that everyone is using in this space work in Azure. And so that's why this kind of different approach almost to thinking about actually how do we make this production ready? How do we take this into real life and manage it and audit it and work on it as a team? And so I see that as the real exciting part in some senses of Azure Machine Learning. And I can only apologize. My internet seems to be struggling quite a lot here. I'm trying to think if I have a video I could play. Let me just close these. We'll try again. But really great questions. Thank you everyone for asking such interesting questions. And you didn't miss a lot. Don't worry. Like you can join in now. We'll do some other examples. So we just need to take a quick look at one that I ran earlier. That's all I need from you, internet. Come on.
Yeah, it's taking a while, but and let's talk a little about what you talked about, the automation part of the machine learning, right? So if you did have this automation part, Amy, what someone would have done is they would have plotted a graph, maybe on Excel. They would have looked at trends on what are the possible trends, and they would have gone to maybe some IDs like Spider or Python, whatever, or VS Code. They would have figured out what are some different p values and check what are the different columns that are not behaving properly in a machine learning studio. So that I think for a data scientist, data pre-processing is something that really takes a lot of time, and one has to come back every single time when they train a model and look at the accuracy. So I think this is where Azure Machine Learning automation has really saved the time of a data scientist or any person who is working on a project, is that they would run all the best possible algorithms taking with the columns, and they would give you the accuracy. Having said that, one of the major concern is indeed the cost, because computation would cost a lot. But you said it would only cost you by the time it is running, because people would be surely concerned about the costing, because when you run so many algorithms, right, and there's a lot of computation that we need. And best thing is, as you said, you can run any of the open source libraries. It may be Keras, TensorFlow. I believe it may be OpenAI Gym too. You can all run that on Azure Machine Learning. That's great. Also, I believe Python comes really handy with VS Code. Microsoft has been working really great with the extensions that they have brought. You can do the entire Jupyter notebook inside VS Code. That is something that I really love. So the things that are really amazing. Also, we have Jupyter's also on a local machine. The best part of doing that Jupyter on Azure is like it's there. It's always there. It doesn't matter if you come back after 4 years, your notebooks are still there. You can just click and run, set the kernel, which Python version you want to run, and it's still over there. So those are the things that I think Microsoft has really worked nicely, and it has been there for a really long time, and people yet need to explore that part. One question, Amy, that I would like to ask you is that all that you're showing today is from a paid subscription, or you have Visual Studio or a subscription, right? What about the guys who do not have the subscription? How should they move into it? Because all the things that you have shown is pretty fancy, and anyone would like to go ahead and get started.
Yeah, so number one, you will need an Azure subscription to start with this. So even if it's the free trial, like go to azure.microsoft.com/free trial, /free, sorry, and it will give you, it's around $200, I think, for a month. And
that's a lot.
That will really get you started. Yeah, like you won't need that, I promise you. Like if my monthly bill was $200, I think my manager would be like knocking on my door. So I'll be honest with you, like we have to be very, very crude about what we use in our subscriptions, just like customers do. And one of the interesting pieces there is kind of thinking about that the pricing that sits behind it. And so when you then come into the machine learning studio, if you're just using things like notebooks, the only thing you'll pay for is the compute. Whereas if you do want to use some of these extra services that we've built on top, and they do make your life a lot easier, they are at that extra cost of the enterprise subscription. Again, it is just a creating point. So when you're creating the machine learning service in Azure, you either select basic or enterprise. I'll be honest, like I don't see it that much in my bill. Like that is not what's costing me the money. The things that are costing the money are things like Azure Container Instances and Azure Kubernetes to deploy these models. And then any virtual machines that I'm running. That's the main thing I see in my bill. It's not the actual kind of payment for the service in some senses. So do keep that in mind. Let me try and show you here the one of the ones I ran. I can only apologize for my internet. I'm so sorry about that.
It does happen, live shows does happen, and the demo demon always comes in during the live show.
Yes, I know. I have such good stuff to show you. So if we don't get through it all, here's a promise for you. On Monday, I will record all these demos. I will send them to you, Stephen, and maybe you could share them with your audience as well, however you normally get information out to them. So yeah, I can only apologize. Sorry, I need to get on the phone to my internet provider, I think. But here we go. So say that we've completed, and so I have this support ticket regression. Here's one I ran earlier. We can see that it ran for 32 minutes. I ran it a few days ago, so I need to know how I ran it. Like, what was the setup, right? I used CPU compute. It was done by me. This was the data set that it used. So say you're working with a team member, it's not a problem. You've got all the information you need. All you would need to do is IM them potentially with like anything that they were thinking. And then on the left, it gives you the best model summary. And so here we can see the voting ensemble. So an ensemble is a very powerful algorithm. I'm not surprised that it's done so well here. It's basically a mixture of multiple algorithms, and it chooses the path that it wants to do that will be most optimal depending on the data point. And then you'll see that it's given us our root mean squared error. It's okay. I'll be honest, it's not great, but that's the data set. So we would want to do more tuning, or we would want to look at to see actually, can our data set predict this? Is this a predictor? Is this something that we should be putting into production? But we can also view all other metrics. So it's not just the one we choose is the only one it tracks. It's just the one that it's trying to optimize. And so this is super interesting to see all these different metrics. And it tells us that this sampling, it basically took 100% of our data and therefore is doing cross-validation. So for those who are in the space, when there's training and testing data sets, you train on a subsection and then you keep some of it back so that it's never seen this before, and then you test whether it's any good or not. In this case, it's doing cross-validation, so it will split up your full data set. So it will take off this bit in one run, and then it will take off this bit in another run, and then it will take off this bit, and then this bit, and then this bit, and that's called 5 cross-validation. We were talking about the pre-processing. If you click on data guardrails, when it loads, this is where it tells you about the pre-processing and the decisions that it's made. And again, if you go to docs.microsoft.com and search in the Azure Machine Learning documentation, you will see that it actually has pages for how does it do this. And then when we click on the models tab just here, this will then show us all of the different models that it ran in order to get to the problem. So remember, the reason that this was built, because I would have to write code for just one of these, track all of the outputs, and then change it slightly and rerun it, and then change it slightly and rerun it, and then change it slightly and that is a lot of time. Like, that takes so long. That takes way more than 30 minutes of my time.
Yeah,
and so
exactly.
it is incredible what it can do. And so here you'll see that it's ranking them by our normalized root mean squared error. But I mean, look at the amount that it runs. It runs about, in general, up to like 30 each time it does it. And so it's fascinating to see those different runs. You can also dig into like the logs and see actually how it ran. So if you normally code in this space, I recommend looking at that. But when we go to the details page and we choose our best algorithm, one of the interesting parts about it, so we'll click on voting ensemble, we can actually dive into that specific model. And when we do, it will tell us a little bit more about it. I mentioned the interpretability. This is where you would see it. So you can click on the explanations tab and it will start to load up your interpretability. You'll explain your best model. So thinking about you know, the why of why you're doing this, and actually what in the data set is really pushing it. But what I wanted to show you was you can literally click. So say this is right. You're like, this is great. This is exactly what I need. And I need to get something out into an environment that people can actually use it. You can click on deploy here, and it will then deploy this to an Azure container instance. So we can give it a name. So we can say Tailwind Traders support ticket -v2. Just let it catch up with me just there. There we go. You can give it a description. You can choose the compute type. So AKS is Azure Kubernetes Service, and ACI is Azure Container Instances. Container instances are a single instance of a container. It can scale a little bit and stuff like that, but we recommend for production workloads, you look at using Azure Kubernetes Service because of all the amazing manageability that comes with it. But given that we're in beta here, we're just testing, we'll use that. What does it not like about this? It's very strange. Apologies. Let's put tickets maybe. You can enable authentication. So one of the key things, right, is machine learning models. One of the ways that they can be attacked in technology is actually by people sending rubbish data to them and having the access to do so. And then it'll just like mess it all up. And then that data might be going into a new data store for you to retrain the model. And, you know, you can look at automation around that. And all of a sudden your model is just going, you know, crazy. So it's super interesting to see that you can add or enable authentication, and you can really think this is an API endpoint. So just like any API endpoint, we must be able to protect it. It's just like any other container, right? We wouldn't leave another container out there with no, well, in this case, we are not going to enable authentication, but you would click deploy just here. You can actually add your own custom assets as well. So if you want to add custom scoring scripts because you need to do a little bit of processing at the end, you can do that here. We won't do that because I have, here's one I made earlier type thing. So when you've created one, it takes about 15 to 20 minutes normally until it's fully ready. It will have, it'll be spinning it up and transitioning it and then putting your model into it, etc. When you go into endpoints, you can see the endpoints, so the container instances here that I have. And when I click in on them, it then becomes what reminds me a little bit of like cognitive services. So it gives you an endpoint that you need to call a scoring URI, and it tells you the schema that you need to call it with the data schema. And then you can go ahead and you can actually use that. So just while this loads, really, really good question. A huge thing right now, low code development is mainly, in the past we've done, well, how do I explain this? So I've seen this trend in the time that I've been in tech, and I'm sure many people here have been in tech way longer than me, so I'm sure you'll see it as well, especially in the data science and machine learning space. Things start in research, and we're talking research code as well. We're talking like quite meta level, heavy theory based, not ready for production, right? Research code is kind of different. It's proven a point. It's proven that something is possible to do. And then what we do is we take research code and we bring it closer to production. And then we actually say, well, you know, what we want to be doing here is we want to be trying to get it to become real, and often that becomes some kind of framework or SDK or maybe a package that you actually have and you use, but you have to understand the depths of it in some senses to actually use it. And then we see higher level things, like we see things that were built into Visual Studio Code that will help you pull together samples of scripts, or a framework that actually does so much for you, and you just call methods and insert variables and it does it. But actually behind those frameworks is a lot of complex code. And then there's this next step, right? And I almost see it as like IaaS to PaaS to SaaS in some senses. It's almost like taking it each time a little bit more responsibility away from you. And so low code is now super interesting because it means that actually, if I don't, like I can code, like no worries, but if I don't have to, like, why would I? I know it sounds really, really bad, but like, why would I? If I can get there quicker by just using a tool that's going to help me do that, then why wouldn't I? But also when it gets to low code, it opens up the area for everyone to come and join and be able to use it. And then it means that we don't have to have, because we don't have enough experts, right, in the world. We just don't. Especially in the machine learning space, for the demand that's needed. And so for the ability of people being able to create these amazing solutions that help people use it, that's why I see low code as being so interesting. But back to where we had an endpoint, so an Azure container instance that's sitting in the cloud. It has our automated machine learning model on it, and it has this REST point here, as well as a Swagger definition. So if I open up Swagger is an open source standard that is all for REST APIs and how you call them. And then if we copy our REST endpoint just here, and let me open Postman. Sorry, I should have had that one open earlier. But basically what we can do is we can, hopefully this is loaded. This won't look very nice. This will just be a huge JSON string when it changes. That is telling us what our data schema is. There we go. So it's a bit of a mess. And so one of the neat little tricks that I tend to do is I actually take the whole Swagger definition. I open Visual Studio Code. I paste it in. There we go. And something that you can do is you can do Alt, Shift, and F. And it will actually, she says, let me just get it to select it all. Alt, Shift, and F. Hello.
The demo demon's back.
I know. Why would it go away? And what you'll see, Alt, Shift, and F will then lay it out really nicely, and it's so much easier to read like this. And if you scroll down in this schema definition, it's well worth taking a read through your schema definition in detail. But one of the things that you'll see just after this here is it will give you an example of the data input. And so you can then select this, pop it into your Postman request, your REST API request, and check that it works. That's what I do first. I just put the default data in and then understand the schema, and then I can start pulling together, say like, okay, well, what does that look like when I'm having to put like many, many different things, or how do I build that into my code in some senses? And we have Postman just here that's kind of just loading for me. But one of the things that I mainly just wanted to show you there is it does just become a REST endpoint. And that's the key thing of it. It's not meaning that you need to build in a certain SDK into your code or anything like that. If you can make a REST call, you can call now your bespoke machine learning algorithm that has been built and run against multiple different sources, multiple different algorithms and parameters to actually choose you the best one. Very, very quickly, just for the end, and I absolutely will send some videos out because this has not been as slick, apologies, as I would have liked it. I had so much more to show you, so I will definitely get those out to you. And actually, they're really useful then for if you want to step along with me, you can pause it and stuff. But if we go to forecasting, forecasting is a new piece in this space. So it's something that was added more recently, and there is some amazing stuff. Forecasting is actually a very, very hard, but I think it's quite a hard problem to solve. You have to think a lot about other things compared to the other algorithms. You have to think of things like lag and how one variable associates to another in a time series. It also uses very, very different algorithms for these kinds of approaches. And so one of the things that I've found is actually automated machine learning has really done a great job of teaching me a lot more about forecasting. And forecasting is so useful in businesses, right? Thinking forecasting sales, forecasting demands, forecasting need for something, etc. Is all very, very important. And we can see here, let's go to run 100. That was my last one. I am able to set up the problem, but all it does is give me a few extra options and that I'll select. And so, yeah, I'll record something up for you on this piece around forecasting, and we can kind of dig a little deeper into that in there. But it all looks the same, and so you get the same setup. So the interesting thing when I was learning about the forecasting bit was because classification and regression I'm very well practiced in that space. I felt very comfortable that the step into forecasting was a lot smaller. I did have to do quite a bit of reading around like some of the different types of approaches that are used, etc., and what some of these variables mean when it's asking me to set them. But other than that, it does a very, very good job. And so it does things like it automatically detects the step in your date time. So in your time series, say you have IoT devices, your actual series might be every minute. whereas in a transactional database, your series might be every day or something like that. And so it's able to detect that automatically. It brings in all of the forecasting, the lag, and the understanding like how it predicts each value depending on what you're trying to forecast. And so I'll definitely send you some more stuff, but you can absolutely do that with automated machine learning as well. And so I guess because I'm a little bit over, and so I want to be very, very conscious of your time, I just wanted to share with you some of our amazing links. So just here, if you want to keep learning, as I said, I will send out some videos. Stephen, I'll send them to you as soon as possible on Monday. The best place to go is to go to the documentation. I've brought it up over and over again there. It's aka.ms/mythbuster-automl. So that will take you to a place where you can start understanding automated machine learning more. I did mention understanding the metrics, I believe, is incredibly important. So I've actually got you a short link there specifically to the page that does understanding of metrics. So that's aka.ms/automl-metrics. And then for all of the Azure Machine Learning documentation, it's at that link there. So that's docs.microsoft.com/Azure/machine-learning. That's where you'll get everything in that Azure Machine Learning portal. But I also recommend going to Microsoft Learn because the Azure Machine Learning platform has a few different modules in there that might be a great source to have a quick look over. I also wanted to share, I've started to do this more because I think it's really important, some influencers in the space. So some other people that I know are working in this space. And so I have a few people for you here. These are their Twitter handles. So Francesca is on our team. She is an absolute expert in data science, and she's also a very, very savvy forecasting person. She is the person I've learned a lot about forecasting from. We also have Ari Bornstein. He's also on our team. He's very, very into things like natural language processing, but is an absolute superstar around the Azure Machine Learning platform and some of its deep technical elements around the SDK. And then also a gentleman in the community called Vlad. He did this amazing talk. It's a part of the global AI community, which I've just put at the bottom. And he did an amazing talk where he used automated machine learning to help him with a Kaggle competition. So Kaggle competition. Yeah, and it's such a good talk. So go check out Vlad. Go check out the global AI community as well. I know, Stevie, I know you're a big supporter of the community. And in there on the YouTube channel for the Global AI community, they actually have Vlad's talk. So I highly recommend going to take a look at that as well.
You forgot to add your name, Amy.
Yes, yeah, I'm just at the bottom here, so right in the bottom corner, I'm at Amy Kate Nico. So yeah, if you want to follow me, that would be an absolute treat. I tend to share pretty much just a really broad spectrum. I've done things in Designer, in low code, as well as looking at things like our SDK. So yeah, a bit of a broad brush approach, but often just the ability to use the technology is a place that I like to kind of show people that kind of element.
That's great. That's great.
Yeah.
So one thing, Amy, that you did cover, that you said that it was in the paid subscription, but you can somehow manage and go get started even with with simple credit and debit cards. But we do have Azure Machine Learning Classic, right? If not all, there are options available. At least you can go and get the data set, you get all those algorithms, and you can also go and get started by create. Once you train your machine learning model, and then you go and create those APIs, it does allow you to create APIs on the fly. It would add the input and the output node all on its own. So even if you don't want to go and give your credentials, you can still go, and with a simple Outlook account, you can get started with the classic Azure Machine Learning Studio. Well, and I think Amy, that was a really great session that you put along, right? It was an amazing session. You started with what is actually automation with machine learning. You went on to explain with examples, right, how it saves your time with pre-processing. Then, of course, then cleared the demo demon. It didn't work, but
I know
it does.
I'm so sorry. Oh, it's such a shame. I have some amazing stuff lined up for you, so I can only apologize. I hope it's been useful to just hear it talked through. We did get through kind of that one cell. However, as I said, I'll do a demo recording. I'll send it out, and that will be a lot quicker through the process. Yep. It will give you that sense of end to end. But I hope this conversation has also been useful. And thank you so much for your questions as well. They've all been really, really good.
That's great. That's great. So thank you everyone who has joined us for today. I think we reached a really good audience, and thanks for everyone who has asked questions. So Amy, let's just wrap it up. I think I had a great eye, and the entire viewers had a really great time. I, Stephen Simon, on behalf of entire CSharpCorner community and its millions of users, would like to thank you for your valuable time and your contributions towards the community. We would love to have you back next whenever you are available, and looking forward. Thank you. Stay happy and enjoy your weekend.
Thank you.